HPA is the number one topic of conversation amongst our backers right now.
Yes.
And they have a few different questions that I think we've answered on the FAQs and a couple of things. But I guess the major question right now is the design philosophy of HPA. What is the philosophy that you're following in your design?
Okay. When we design any analog circuit, not only about a headphone amplifier, I always care about one thing first. What's the power supply? What's the power supply circuits there? Reason is a lot of people think about analog just analog, which is actually not. The power supply there actually is in conjunction with the whole signal chain. So taking care of the power supply first usually will be very easy for you to make a good sounding devices because you provide a very nice environment. Without a good power supply, no matter how good your active amplification components, how good your topology is, you cannot make it good. So power supply is the first. So in a headphone amplifier, HPA, we use, let's talk about solid state first. Solid state first, I would love to use again a bipolar power supplies on the input buffer. And also I will have a very nice shunt regulated power supply for the amplification on the voltage too. And again, let's talk about the last stage for the circuitry to drive the current to your headphone. We call the headphone driver, the current driver, or the current amplification. We will use the instant power technology there. So when there's more current demand, we will release the energy. Boom. So give you the last punch. So on the power supply, I'm taking a lot of details on that part. That's the first thing. Second thing I want to talk about, someone asked about what's the solid state topology I'm using there. Now the answer I tell everybody, and also said in forum, is it's a hybrid. I mix the op amps and also the solid states.
So they're asking, is it discrete or is it op amp based? And the answer is it's both, right?
It's both. And we use the best of from two words. So I also share there is about 10 years ago, I'm kind of like designer, I will insist discrete only, no negative feedback, a lot of like we call very, very classical tradition designers point of view, which is usually works out very well. You can have a very good sounding devices by following that principle. But I call myself, that's a phase one time. On the phase two time, trying to challenge myself that could I make a good design based on the op amps, based on still have the negative feedbacks. In the end, I did it. I used several of my audiophile guru friends, and we talked. I asked them, can you do the A/B test? Tell them, do you feel this the discrete or the op amp? In the end, they cannot tell the differences. So as I think, I make another stage. And after that, I have a lot of, I learn more. I know there are many other ways to make op amp and the discrete components, they work together very well. Like you use the minimum shortest negative feedback path. You put some special circuits, constant current to make the op amps always running at class A stage. A lot of tricks there, but anyway, I think I'm on the phase 3. We can freely use whatever components or topology we want to use to make the sound we like.
So some of those tricks that you just mentioned, like the short negative feedback trace and
binds to the class A.
Yeah, has that all been used in
Yes.
in everything we've done so far?
Of course.
Including DaVinci, right?
DaVinci, we use a little bit different stuff. But some people ask why their Geek Pulse headphone amplifier part sounds so good. That's one of the best op amp implementation they have ever heard. I think it's easy because it's not only the op amps there. We use a lot of other things.
Okay. Well, the next question people are having, so we've talked solid state, now let's talk tubes.
Mm-hmm.
Okay, so we're going to post the topology chart or the graph that we've done before for
Yes.
Pulse and everything on the campaign as soon as I draw up your drawing, right?
Yeah.
We got it over on the wall. But the question that I asked, which I thought was a natural progression of looking at that chart, is in the tube version of HPA, you've got balanced solid state topology, then single-ended tube topology, and then a balanced current driver.
Yes.
So why go from balanced to single-ended to balanced, or what's your, I guess,
That's a very good
what's informing
question.
that?
First of all, it's a design choice. We can still make the balance amplification stage from the tube, no problem. But in my mind, I try many times. It always feels to me that single-ended architecture is the best to fit the tube, make the tube sounds as like a tube. So in the tube version of HPA, we still has the balanced input buffers made by the hybrid of the op amps and discrete components. And then you will see that in diagram, we will have the tube VAS there. In that case, that's the single-ended architecture. And when we want to output the current to your headphones, which we drive it well, we go back to a balance. So the tube version of the HPA is somehow very special. It's balanced to single-ended and single-ended back to balance. We have the tube in the central, that's a single-ended architecture, driving by a constant current source.
What about, so we've got a balanced current driver, but when people are using the single-ended outputs of HPA, how does that work?
Oh, that's another good question too. So, for example, when we use 4-pin balance output, right? We use one amplifier to drive the left plus, left minus. We use the other amplifier to drive the right plus and right minus. When we take the single-ended output there, we just take the positive side of each one. So we got the left positive, right positive going out to a single-ended. So actually, you can use balance and single-ended headphones at the same time. Plug it in, you can hear a lot of fun stuff.
Oh, okay, let's see. The last question I think I would ask that I've been answering tickets. So I've got some questions regarding using Geek Pulse with HPA, because some people are saying I've already got an headphone amplifier on Pulse. Why do I need HPA? Which I think is a fair question.
Yes.
And then the other part of that question is, Pulse has digital volume control and HPA is analog volume control.
Yeah.
So how do you, if you're going to use both, what do you do?
I need to control this. This should work.
Yeah.
Oh, in the ideal case, in our usage scenario, this is HPA. It has two inputs. So one can go from the Geek Pulse stack, and one from the other analog source. So that's the first benefit when you use HPA. You can put, for example, CD player. You can put whatever, even your iPhone, going through this analog input, and the HPA can give you 3 types of the output. Super driver, big 10, normal 1, IEM. And this is a special design too. It's not very popular that you can see 3 dedicated output, so you can see there. And let's talk about the volume control. We have 1 knobs here. Use A, okay? We have another thing, D. So digital volume control here, analog volume control here. How to make the best of it? Okay, first of all, you need to know one thing: the strengths of analog and the strengths of digital. When we talk about digital volume control, the best case we will love to use it is always divide by 2, because 0101 is binary thing. This when you have a signal like this, you make the whole overall swing amplitude going to half or 1/4 or half of the 1/4 will give you the best result. You don't lose too much thing. You don't lose a lot of integer control errors. So for example, how to make that divide by 2 happen on digital domain? We use here. I would suggest us use 3 dB, 6 dB, 9 dB, 12 dB. Try not to use the number in between. For example, -4, -8, -11, something like this. Because when you have analog volume control, you can set the big step on digital domain. And after that, you fine tune that a little bit here using analog volume. That will give you the best result.
So I know that people have been playing around with the gain of Geek Pulse, right?
Yes.
So you've got high, medium, and low. And I actually think you caught me doing this, where I had my gain set to high, and then I was pulling it back, 35 dB or something like that.
Don't try not to doing that because say the funny thing is, for example, sorry, I need to use another space.
Sure.
Okay, you set the gain high, medium, low. You have a room like this. This is much higher. This is medium. This is very low. This is total room you can swing when you set the different gains, high, medium, low. And when you do the digital volume control, you are trying to control the signal in between. So say if you are using high and you doing minus 35 dB, so you make a lot of room here, but you lost a lot of bit depths. You lost roughly how many bits? 3 or 4 or 5 bits there. So it's not right. The best thing you should do is you try to switch back to medium and make it maybe minus 6 or minus 4. No, not minus 4, I tell you. Minus 3. Minus 3, minus 6, minus 9 will give you the best result. Or even go lower, use the low gain setting to see if your headphone still got drive it perfectly with it, and maybe minus 0, minus 3, minus 6. A lot of people love to use minus 0 because that's what we call bit perfect.
All right. Thanks, Larry.
Thank you.